So the generalized formula for acids, HA. H represents the hydrogen ions. A is the rest of the acid formula. And I've got some examples at the bottom of the page, which I'll get to in a second. There's different kinds of acids. We can break them up by what their chemical formula looks like. Binary acids are made up of hydrogen and a nonmetal, not some nonmetals, a singular nonmetal. That letter A is important. An example of this would be something like HCl. You've got hydrogen, you've got a single nonmetal ion. Binary acid. There's also what are called oxyacids. And now an oxyacid is made up of hydrogen, oxygen, and another element, one other element, whatever it happens to be. An example of this would be something like this, H2SO4. You've got hydrogen, you've got oxygen, and the one other element here would be sulfur. Almost always, but not always, almost always, the formula for an acid starts with the presence of one or more hydrogen atoms. There is one exception to this, hydrogen, not hydrogens. It should just be singular. Hydrogen atoms. Another example of this would be something like H3PO4. The hydrogen is listed out front. The notable exception to this is this acid down here, CH3COOH. Sometimes this is, and really it should be written as HCH3COO. We just take this H from the back and we move it out front. Does anyone recognize what this guy is, the CH3COO? Something you should be familiar with, something you are familiar with, whether you recognize it or not. It's like when I run into a student at the mall. It's like, I know you, but in this context, I forget who you are. You know this, but perhaps in this context, you forget what this thing is. Sorry? Malik, you remember? No. Sorry? Remember it? What is it? It's acetate. This is the polyatomic ion acetate. You'll see it on your table as CH3COO-. When you bind it with H, this thing becomes what we call acetic acid, which is something that, believe it or not, you guys are all familiar with. Well, you should be familiar with. If you're not familiar with acetic acid, you should try it. It'll make your life better. Here are some examples of common acids and where they show up in your life. Most acids are ionic compounds. And I've got a list here, and we're going to add two more to the bottom. The first one, the most common one you guys carry it around with you all the time, whether or not you recognize it or not, is HCl. Commonly known as hydrochloric acid, because there's the hydrogen, there's the chlorine. It's also called muriatic acid. It's also called gastric acid, because yesterday Soham called this thing not gastric acid, but stomach acid. Its common uses: producing plastic, processing metal, digesting food. Well, I'll just say digesting. It digests whatever you eat, regardless of whether or not what you've eaten is food. For example, there's like Guinness World Records of people who eat metal. A guy ate a whole plane just because you can. The stomach acid that you produce will deal with that. It's not healthy for you. You shouldn't do it. But your body is prepared to process it, believe it or not. I think I talked about it with the other class, not with you guys. So you guys carry around this acid with you all the time. It's in your stomach. Acids, when you typically think of an acid, I mean, I grew up in the 90s. The 90s were really big for disaster movies. One of my favorite disaster movies of all time is Dante's Peak. Hands up if you've ever seen Dante's Peak. So sad. Over spring break, if you've got nothing better to do, go watch some 90s disaster movies. Dante's Peak is a great one. Stars Pierce Brosnan, also known as the 90s version of James Bond. It's a volcano movie, and at one point, Grandma has to get out of a boat to save her grandchildren, and the lake is turning to acid because of all the sulfur that's coming out of the volcano. Grandma, and this is what we think of when we typically think of acid. Grandma gets burned alive, disintegrated alive by the sulfuric acid created in that lake. That's generally what people think of when we think of acids. At least growing up in the disaster movie 90s era, that's what people think of when we think of acids. But you carry a bag of this stuff around with you all the time. That's functionally all your stomach is a bag of acid. Why doesn't it eat its way through you? Why does it not digest you? Does anyone know? There's something special about your stomach. Well, the inside, it better be on the inside of your stomach. There's a lining between the muscle that makes up your stomach and the contents of that bag. Do you know what that lining is made of? Does anyone know what the lining is made of? Michael? It is a mucus lining, you betcha. So you've got a mucus lining that your body is constantly producing to protect the muscle that is your stomach from the acid that's trying to dissolve everything inside of it. Does anyone know what happens if that mucus layer gets disrupted? Which you can do relatively easily. You get ulcers. That's what an ulcer is the hydrochloric acid in your stomach trying to burn its way out. If you have portions of your body that aren't protected by this mucus and that acid gets there, it can form an ulcer. What is it called? If the stomach acid makes its way all the way through. If anyone watches medical shows, the ulcer starts with a P. No ER, house, medical drama kind of things. Okay? We say the ulcer has perforated. What that means is the stomach acid, there's now a hole in your stomach to the rest of your abdominal cavity. If an ulcer perforates, that acid that's inside there, being contained by the mucus lining, gets out and now has free reign to digest all the rest of you. Really, really bad. That mucus layer is really quite important. And it's not hard to disrupt that mucus layer. For example, I have a cousin. My cousin decided to spend the majority of his 20s serving his country overseas in exactly the way you think serving your country would look like. He came back and coped by drinking way more alcohol than a 20-year-old should. When you consume a lot of alcohol, you can damage the cells that produce that mucus. And so he got wicked ulcers. A symptom of alcoholism is ulcers. Another thing this can do, hands up, have you ever had heartburn? You've experienced this personally. Only 3 of you? 4 of you? Wow, lucky you, the rest of you. Heartburn is caused by that stomach acid making its way up out of your stomach into your esophagus. That esophagus doesn't have the same mucus lining. It doesn't have to, because your stomach acid isn't supposed to go there. And so when you feel that burning, usually starts, and the reason it's called heartburn is because it starts in the middle of your chest, which is where your esophagus meets your stomach. It starts to make its way up because of, there's a whole bunch of reasons it can happen. And you start to get that heartburn, which is why we take, well, something on the next page to kind of deal with that. So useful, your body needs this. You absolutely, if you didn't have the HCl, you wouldn't digest anything. But you got to be careful with it. Your body needs to have ways to treat it, and thankfully it does. So that's one that's you should all be very familiar with. Another one is sulfuric acid. This is the, for lack of a better word, the sexiest of all the acids. When I say sexiest, I mean most commonly known, because it is arguably the gnarliest. When you see an acid just eat its way through something, it's almost certainly sulfuric acid. It's the most dramatic. It's got the most flair. It will eat through everything. It is commonly used in car batteries. Sulfuric acid is nasty. It's really cool. Really nasty. We have a teeny tiny bottle of it in the lab. I will. I'll demonstrate a reaction for you guys with sulfuric acid when we come back from spring break. Sorry? No, you're not allowed to eat it. It basically one of the reactions that you can do is you can take a big pile of like sugar, like you would put in your coffee, put a couple drops of sulfuric acid on it, and the whole pile will burst into flames. Like sulfuric acid's wild in what it is capable of doing. So I will not. No, you guys don't get to play with it. If we haven't used, and we only have the bottle. When I say little bottle, I really mean it's a tiny bottle. Nitric acid makes explosives, makes fertilizers. Obviously, we don't have this. I'm not into making explosive. Well, I am into making explosives. Not with you guys though. Nitric acid is commonly used for those two things. This one, CH3COOH, I listed it up here. This is called ethanoic or acetic acid. This one is wildly popular all around the world. Does anyone recognize or know the common use for acetic acid? We commonly dip things in this, both bread and potatoes. Keep going. Vinegar. Acetic acid is vinegar. It is a delightful little acid. If you're not into, fries and vinegar, salt and vinegar chips, you haven't really lived. Balsamic vinegar. I don't know what I would do without balsamic vinegar. It's a delightful little additive to so many things. Salads, breads, barbecue. It's an acid, just makes things better. Phosphoric acid is used for a whole bunch of things. Used in flavoring food and in beverages. It's used in dental products because phosphorus, that letter P right there, is actually absolutely necessary for your body to build more teeth. And so we find phosphoric acid in dental products. It's used in cosmetics, used in skincare products. Carbonic acid is another one. Also just makes the world better. Does anyone know where we find carbonic acid? The name gives you kind of a real big hint. And what is CO3? It's a polyatomic ion. What's its name? It's carbonate. Which means if you have H2CO3, you have carbonic acid, which means that whatever it's in is carbonated. Any carbonated beverage. Any carbonated beverage, any kind of pop, even if you have one of those soda streams at home. My kiddos are still too young to understand the concept of acidic, so my wife and I just call it spicy water. Gets the point across. My daughter's not a fan. She doesn't like the bubbles. As long as the lid stays on a carbonated beverage, the carbonic acid stays in solution. It stays dissolved in the water. What happens as soon as you crack the lid on a carbonated beverage? Sorry? The bubbles come out. Those bubbles are what? It's not air. It's not oxygen. Carbon what? What did you say, Vikram? It's not carbon oxide. It would be carbon dioxide. That's the gas that's produced when you crack the lid. So let's take a look at what happens here. If you have a carbonated beverage, there's carbonic acid in it. You crack it, the CO2 all rushes out. So if the CO2 is gone, it leaves the carbonic acid. What do you have left over? Well, the C is gone. 2 of the oxygens are gone. So what are you adding if the CO2 leaves? H2O. What do we call it when the extra H2O from the carbonic acid makes its way into your beverage? We have a name for this. We say that the pop has gone flat. Because what you've done is you added, by allowing the CO2 to escape, you've added a whole bunch of extra water unintentionally to your beverage. Now your beverage doesn't have that same, the Coke doesn't taste quite as Cokey. The Sprite doesn't taste as Spritey. Because allowing the CO2 to leave adds a bunch of extra water to your beverage. How dare you? How dare you? Yeah, go for it. Do whatever you gotta do. Okay, let's keep going. So there are some totally necessary, wonderful, delightful tasting acids. Hydrofluoric is another one. Don't consume this one. It's used for manufacturing and etching glass. When we say etching, like burning patterns into glass. Hydrofluoric acid will dissolve glass. It's wild. Very dangerous. Two other ones that we'll add here down at the bottom. One of them is HC6H7OH. Sorry, HC6H7O7. I don't expect you to recognize this. This is citric acid. Also makes the world tastier. Citric acid found in citrus fruits. Anything sour that you regularly consume, lemons, oranges, limes, any citrus fruits. If you have gummy worms or those little key-shaped things that have that white powder on that top, the white powder on the top is crystallized citric acid. It's citric acid before you dissolve it in the water. Yummy. I quite like it. You might not, and that's okay. Another one is this. You should be familiar with, well, it is necessary for you to be familiar with this guy, C3H6O3. Sometimes it's written as HC3H5O3. You pop one of the H's out and move it over there. This is called lactic acid. Anybody familiar with lactic acid? Sorry? Lactic acid builds up where in you? Nope. Where does lactic acid build up in you?
Oh, lactose intolerant.
No. It's not lactose. Lactose is something else. Nope. Lactic acid what builds up in your muscles when you're working out. It's also a food additive. So there's all sorts of acids. Some of them are really gnarly, have pretty intense uses. Some of them are totally benign and have delightful, tasty uses. Those are your common acids. When you're ready, flip the page. Let's talk about some bases. Bases are compounds that release hydroxide ions. In an aqueous solution. For example, if you take NaOH, you dump it in water, you're going to get NH plus and OH minus. Anything that adds hydroxide ions to a dissolved solution is a basic solution. The general formula for an acid had the H out front followed by an A for acid. Anyone want to take a guess at what the generalized formula for a base would be? Something OH, and we used HA, the A stood for acid. Well, A stood for acid. HOH would be B, yeah, it should be BOH, B for base. HA, because acids release H, A for acid. B for base, bases release OH. Bases are something you encounter every day as well. They're totally useful, very necessary for you to experience in your life. The bitterness of coffee, for those of you who like your coffee. Coffee itself makes you more acidic, but it tastes bitter because there are basic compounds in coffee. It's kind of counterintuitive. You get the taste of the bitterness, of the basicness, even though coffee will make you more acidic. It's complicated. And the slippery feel of soap. Slippery feel of soap are due to basic compounds. Again, most of these are also ionic. Compounds made up of a metal and a hydroxide ion. Specifically, the first two columns of the periodic table Lithium, sodium, beryllium, magnesium, potassium, calcium. Those ones are the more common bases you'll experience. But some of them are others as well. Here are the common ones. Now, the acids, when we typically think of something that's going to burn you in the lab, we think of acids. But really, if you want to play with things that are more dangerous, you play with the bases. The bases are pretty gnarly. The first one is sodium hydroxide, also called caustic soda, also called lye. It's used as a drain cleaner, an oven cleaner. It's used in making soap and making paper and in treatment of water. Yes? Well, it's used in making paper. It's used in making paper. It's not an ingredient of paper, but it's used in the process. Has anyone ever seen? I hope you haven't, because I hesitate to bring the movie up, but I'm going to anyway. I hope you haven't seen it yet, because you really shouldn't have. But at some point in your life, everyone needs to see the movie Fight Club. It's wild. Hands up if you've seen the movie Fight Club. Okay. They use sodium hydroxide in that movie in the form of lye. What did they use it to do? Memphis. They use it to burn his hand. They use it to do some other stuff too. Vikram? They don't blow up. No, that's not what they use it for. It's not the explosive in the building. That would be the nitrate. The nitric acid is used for explosives. This is not used for explosives. If you can burn your hand with sodium hydroxide, what's to stop it from burning all of the rest of you? The answer is nothing. You know how they made soap in that movie? Do you remember how they made soap in that movie? They dissolved what in those barrels? No, they used lye to dissolve bodies. Whole people. Lye is nasty, nasty stuff. No, you cannot. If it will burn you, it will burn. There's nothing to stop it from burning through all of you. It will dissolve every part of you and leave nothing. Metal. It will not, to my knowledge, it won't burn through metal. Anything organic. So what? Yep. Can we do experiment? Nope. Because this stuff is dangerous. There are some experiments I'm all for. My chemistry teacher in high school, we made flashbang grenades. It was awesome. We made smoke grenades. It was cool. Outside. We made thermite, which I'll do for you guys. But no, I won't do just anything. This stuff is wildly dangerous. So that's the first one. Sodium hydroxide. It's a base. It's a cleaner. It really, all it's doing is it's the ultimate clean. Dissolving its way through everything. Organic. Magnesium hydroxide is a base that has a really common use. It's called, it's another name for this is milk of magnesia. I will show you this in the lab. It's an antacid. So when do you take an antacid? When you have heartburn. The reason you have a heartburn is because you've got hydrochloric acid from your stomach making its way up your esophagus. It's not supposed to be there. So you take a Tums, which is a chewable tablet, which mixes with your saliva, becomes a basic solution, becomes an antacid solution as you swallow it. Or milk of magnesia. It's called milk of magnesia because it's white. It has a milky kind of texture to it. It doesn't taste like milk, but it looks like milk. You can drink it, and it has those same antacid properties. It neutralizes the stomach acid. It stops the burn in your esophagus. Calcium hydroxide is used for soil and water treatment. Household ammonia. This one's a little bit deceptive because so I've used that name ammonia with you guys in the past. Generally speaking, ammonia refers to NH3, but if you go to ammonia at room temperature is a gas, so that's not useful. So to make it not a gas, what they do is they take the ammonia and they dissolve it in water. One of the H's from the water joins the NH3, turns it into NH4, and then what you have left over is just the OH. So dissolving ammonia in water produces NH4OH, called household ammonia, used as a cleaner, it's used as a refrigerant, it's used as a food additive because you need nitrogen in your and ammonia in your system as well for your body to produce certain things. And KOH, potassium hydroxide, has similar uses to sodium hydroxide as well as being used in batteries. The acids are the sexy dangerous compounds. The bases are not. They're not nearly as dramatic. People aren't being like, ooh, bases. But arguably speaking, these things are more dangerous to you personally than the acids are. Okay, when you're ready, flip the page. I have thrown down a table for you. We're not going to, we'll reference this. Sorry? In what? I didn't get the name. Your voice kind of trailed off when you said it. What's the name of the medication? Pink Lady Medicine. There it is. Huh. It is a gastrointestinal mix. Yes, yes. It's a liquid antacid, so milk of magnesia. Something called viscous lignocaine, which is a painkiller, and an anti-chlorogenic agent, so it's designed to neutralize the chlorine in your stomach. Yeah, that's exactly what it's for. It's can be an effective treatment of dyspepsia. Interesting. Oh, interesting. So it is used. Oh, okay, cool. So one of the symptoms. So Angel's asked a good question. One of the symptoms of having a heart attack is having chest pain that mimics heartburn. So to determine whether or not the chest pain is heartburn or the chest pain is a heart attack, this Pink Lady medicine that you're talking about will be given to a person experiencing it. And if Pink Lady takes away the pain, it's not a heart attack. If it doesn't take away the pain, it's probably a heart attack. That's what it's. According to the Wikipedia article, that's what it's for. Okay, so here's some properties here for you of acids and bases. Again, these ones I'm going to star this, I'm going to star this. We're not going to be doing these in the lab. You are not tasting, you are not touching. Take my word for it. Acids taste sour, bases taste bitter. Some examples of things that you do drink is things like any citrusy juices, 5 Alive, orange juice, lemon juice, lime juice, taste sour because of the presence of citric acid. Bases taste bitter. A beverage that you can go purchase that will taste this way is tonic water. So there's carbonated water and there's tonic water. Those are different, even though they're both kind of carbonated. Don't mix those up. Yes. Number just said, did you say just a gin and tonic? Yeah, that's exactly what this is. Gin is the alcohol. Tonic water is what you generally mix it with when you're having a gin and tonic. That tonic water tastes bitter. I hate the taste of it. My wife doesn't. She likes tonic water. I hate it. And that's because of something called quinine. No, carbonated water is carbonated. Tonic water is carbonated water with quinine. It gives that water a bitter taste. Tonic water is carbonated. No, carbonate. So you have carbonated water and tonic water. Both are carbonated, but the tonic water has quinine added to it. I don't know. I don't like it. You'd be adding, basically if you did that, you'd be getting lemon flavored carbonated water, which is basically sort of Sprite, yeah. Totally defeats the purpose. Just go buy carbonated water. It's the blue can, not the yellow can. The yellow can is tonic water. The blue can is, don't screw that up if you want one and not the other. Touch. Acids, many acids will burn your skin. Bases will feel slippery. Indicator tests. This is what we're going to talk about here in a second. These ones we're going to do. Reaction with metals is something that we're going to look at. Indicator tests I'll talk about in a moment. Reaction with some metals. Acids will corrode metals. The act of corrosion produces a gas. Specifically, hydrogen gas. If you take a liquid, you put it on metal, and it immediately starts bubbling, it's producing hydrogen gas, and what you've added is a metal. So added to the metal is an acid. Bases will not react with metal. They just don't. Electrical conductivity. I've worked at some schools that have an apparatus for measuring electrical conductivity. I've seen the one Abby has. It's really old and kind of scary, so I'm not going to use it. Well, lots of high schools have them. Ours just happens to look super sketchy, and I don't trust it not to electrocute me, so I'm not going to play with it. Both acids and bases are conductive. We'll talk about pH here in a moment, and we've already talked about the production of ions. So, pH. Let's talk about pH. When you're ready, flip the page. Yes, not fat pH. Oh, yes. Not fat pH. What does it mean? Like pH? That's exactly what I'm going to talk about. Yes, I'm going to talk about pH balance. You betcha. Well, so I said not pH as in fat, because that just means things are dope or cool or whatever slang the kids are using these days. So, pH scale. Angel said, what about pH balance? That's exactly what we're talking about here. So pH is a measurement of how acidic or how basic something is. And I don't mean basic as in your typical trendy white person. Basic white girl is the phrase that was used in the mid-2000s. I don't know if it's still used. Well, that's not what we're talking about. And I'm not talking about pH as in fat. The pH scale is used to measure acidity or basicness of a liquid. This first word here should be to. TO. To more accurately determine the acidity or basicity of a compound, chemists use the pH scale and instruments that measure the pH to determine what you have. The pH scale usually ranges from 0 to 14. I've seen it go higher than 14. I've never seen it go lower than 0. That doesn't mean it can't, but generally speaking, it goes from 0 to 14. You should be very scared of anything beyond. You should be scared of some of the things on the scale. You should be real scared of things on either side of the scale. Wow, that took a long time for you guys to get a picture taken. There was issues. Clearly there were issues. And we lost Ikpreet. She's somewhere, okay. So, here we go, pH scale. The middle of the pH scale is 7. 7 is the very middle of the pH scale, and you move off of 7. As you go up, you become basic. As you go left, you become acidic. And this scale is what we call in math, well, Math 12, you will learn something about something called a logarithm. This scale is logarithmic. Has anyone heard this word logarithmic before? Okay, cool, none of you. Hands up if you're familiar with the Richter scale. The Richter scale. Yes, so a few of you are. It's the scale that measures earthquakes. How does that scale, does anyone know how that scale works? If you are a 4 on the Richter scale versus a 5 on the Richter scale, what does that actually mean? Does anybody know? Dennis, is that a hand? No. Vikram? Oh, yes, the higher number is on the Richter scale. The higher it is, the stronger it is. Yeah, Michael? Okay, there's too much conversation happening here. I can't hear Michael. Shh. Yes. What? Can you be more specific? You're right. Can you be more specific? When you're saying exponential, you mean powers. Powers of what? Do you? Nope. Worse than that. Bigger than that. Shh. I'm asking the wrong question. You're right. It's exponential. The exponent can change. It can be squared. It can be cubed. It can be fourth or fifth. What is the base number if you're exponentially? Do you know? Do you know? Okay. No. Yes, you can. Go to the bathroom, Luca. Okay, so the Richter scale is 1. It's exponential, as Michael said, which means that every jump on the scale goes up by another power. But powers of what? The decibel scale. Hands up if you're familiar with the decibel scale. Decibel scale is for? Yes, sound. Also an exponential scale. And the pH scale, measuring acidity, also exponential. How these three scales all work the same way. Every time you jump one whole number, so from, for example, going from 7 to 6 is a jump of a single number on the pH scale. What that means is, in actual terms, it's a times 10 jump. So going from 7 to 6, you've only gone 1 on the pH scale, but that means that milk is 10 times more acidic than water is. 2 jumps, going from 7 down to 5, for example, is times 10 again, or 10 squared. 10 squared is 100, so that means that a banana is 100 times more acidic than water is. Jumping a third time is another times 10. 10 times 10 is 100, times 10 is 1,000. So every time you jump, it's another multiple of 10 strength, which means that tomato juice, and now we're getting into things that we classically assume are acidic. Tomato juice or tomato sauce is 1,000 times more acidic than pure water. And now you're starting, because typically you eat a banana, you don't necessarily think of banana as being acidic. You drink some milk, you don't think of milk as being acidic. Both of them are, but now when you're starting to get to tomatoes, this is typically where you start to, in your life, recognize that things are acidic. Grapes, lemon juice, stomach acid goes further down the list. Yes? So like luminosity? I'd have to double check. I don't know the answer either way. I want to say yes, but I don't remember. I know for sure Richter, decibel, and pH are all powers of 10. I think light is different. Yeah. I'll look it up for you, Millie. So that's more acidic. Basic works the same way. Every jump you go up is another times 10. Fun fact, yes? What about it? Totally different, not related. Okay. Blood. Your blood has a pH of just higher than 7, which means your blood is a slightly basic solution. And it needs to maintain a pH, it's like between 7.35 and 7.45, something like that. Anywhere in there, your blood is okay. If it gets too basic or too acidic, your body can no longer function the way that you are functioning. Symptoms of blood pH imbalance are things like fatigue, nausea, sleeplessness. Fatigue but sleeplessness, which is an awful thing to experience. Being really tired and can't sleep is awful. So your blood needs to be basically right there on the pH scale. So let's take a look. I've stolen some of these things down here. Acids have a pH. This is the less than symbol in math. pH is less than 7. The lower the pH, the more acidic the acid. For example, lemon juice has a pH of 2. It's more acidic than milk, which has a pH of 6. Acids have more H plus ions than OH minus ions in them, because acids produce H plus ions, bases produce OH minus ions. And each time the pH value changes by one whole number, the number of H plus ions changes by 10 times. And the word that we use to represent this is a measurement of concentration. The more there are, the more concentrated it is. So lemon juice with a pH of 2 compared to milk with a pH of 6 would be 1, 2, 3, 4 jumps on the pH scale. That is 10 to the 4 or 10,000 times more H plus ions than milk has. It means also 10,000 times more acidic. Yeah. That's a really good question. If you took something really low pH, like stomach acid, and you mixed it with something really high pH, oven cleaner, for example, what do you think would happen? Well, the acid, this is such a good question. You're wrecking a lesson that's going to happen when we come back from spring break, and that's okay. I love it when students ask questions that wreck lessons that are coming in the future, because it means they're thinking, Mr. Keeley. If I take something like hydrochloric acid, which donates a bunch of H plus ions, and something like sodium hydroxide, which donates a bunch of OH minus ions, the H ions and the OH minus ions are going to come together to form what? If I have H plus ions and OH minus ions, it's going to make HOH. HOH is more commonly known as? How many H's are there?
H2O.
2. So H2O, which we know to be water. You take an acid, you take a base, you mix them together. And the reason I picked stomach acid and oven cleaner is because they are equally away from the middle. So they have, oven cleaner would have the same concentration of OH minus ions that stomach has of H plus ions. Oh, you're wrecking my lesson. I love it. Here we go. Oven cleaner is NaOH. Stomach acid is HCl. So if you took stomach acid, which is dangerous, can damage your body. If you have an ulcer or heartburn, you've experienced this. And oven cleaner, which will absolutely kill you if you drink it. Very painful way to die, because it'll dissolve you all the way down. And you mix them together, the H from the stomach acid is going to bind with the OH from the sodium hydroxide. It's going to make water. What's left over? Na and Cl. What do you get when you take Na and Cl? You get not just salt, specifically what kind of salt? Table salt. So when you mix something that can hurt you with something that will absolutely kill you, and you mix them together in equal parts, you're going to make salt water, which you can absolutely drink and be fine. It's weird, but that's what will happen. Great question. You totally wrecked the lesson from 2 weeks from now. I love it.
So what would happen if you put oven cleaner now?
I mean, it'll start to damage the damage will be immediate. But
what's the liquid on the person's eye?
I don't know, but you're trying to distract me from finishing what I want to finish, so I'm going to keep going.
You think you go blind?
This oven cleaner? With damage is immediate, yes. No, these guys are on it. They will know. They will remember. Okay, so the acids. Acids are less than 7. Bases are more than 7. That is the mathematical symbol for greater than. The higher the pH, the stronger the base. For example, bleach has a pH of 12. You can read it off the list up at the top there. It's more basic than baking soda, which has a pH of 9. Both of them, I mean, baking soda we use in baking, but you can also use it as a cleaner. Fun fact, if someone ever borrows your crock pot and burns something onto the bottom of it to the point where they think they have to throw it out, you just pour a whole bunch of baking soda in there, a little bit of water, crank that sucker up to high, and let it go for like 4 hours, and the baking soda will eat its way through whatever was burnt onto the bottom, and you don't have to throw away the crock pot. I know this because a ex-girlfriend of mine did this to a crock pot that I own. She's my ex-girlfriend because she's not my wife. But early in our relationship, she borrowed a crock pot, thought she destroyed it. Like, no. A little bit of baking soda, a little bit of water, cook that sucker right off, is perfectly clean. Why do people use Coca-Cola? Because there's other compounds in Coca-Cola that are gnarly. Pure concentrated Coke they use to clean up car accidents because it will dissolve blood off concrete. It's gnarly stuff. Yes. Yes. Okay, I'm going to keep going. But that has nothing to do with the acidic nature of Coke. It's other compounds in Coke. Basic solutions have more OH minus ions than H plus ions in them. The pH scale works the same though. Each time the pH value changes by 1 unit, the number of OH ions changes by 10 times. So bleach with a pH of 12 has 10 cubed or 1,000 times more OH minus ions than baking soda, which has a pH of 9, because the difference from 9 to 12 is a jump of 1, 2, 3 times. And Vikram already said it. The reason water is neutral is because you have the same amount of H as you do OH. When you have the same amount of H and OH, they come together and form H2O, which we call water. Pure water has a pH of 7. But things become acidic or basic when you dissolve things into water. So if you go and get tap water isn't pure water. There's other things in there which change the pH of tap water. Salt water has a different pH. Again, in the 90s, I'm a child of the era of disaster movies. Acid rain was something that I thought about all the time, way more than I ever needed to because, you know, the 90s and disaster movies. But acid rain is acid rain because in the atmosphere, there are compounds that, when they dissolve into the clouds, create acidic solutions that then rain down. Acid rain is a very real thing. Yes. Is what? If you boil the water, collect the steam, and then condense it, yes, that would be pure water. Because the water will boil at a different temperature than the other crap that's in the water. The other stuff will stay in the pot, which is why if you boil a pot of water all the way down, you kind of get crusties at the bottom. It's everything that wasn't able to boil out, but you'd have to collect the steam and recondense it. We have apparatuses for doing that. That's called distilling. We can do that in the lab. Okay. I am going to talk about one. Yes, Malik. Yeah, okay.
There was oil in the water.
Yes. Unrelated to pH, but yes. It's more dramatic. It's less environmentally friendly, but it's more dramatic to also just, you know, burn the oil that's on top. Okay. No, because I'm not done yet. The next page, if you flip over, I want you to put a big star on top of there and the words HW. Letters HW. HW stands for I want you to do these questions for homework. Flip the page again. There's another list of questions there that I want you to take a look at. And then I want you to flip the page one more time. Find me this page here called pH indicators. This is the last thing we're going to talk about today. So, where was I? Here we go. Guys, stop. pH indicators, very useful things. Most acids and bases are colorless. You will see this in both labs that I give you. There's 2 labs that you're going to do, probably both of them tomorrow. Most acids and bases are colorless in water. So we need ways to identify what you have. And the way to do that is by using what's called a pH indicator. We need something to tell if it's an acid or a base is present, and we use something called a pH indicator. To test for acids and bases. pH indicators are compounds that change color when exposed to an acid or a base. And we have a bunch of these because they change colors at different points on the pH scale. Unfortunately, I cannot photocopy in color because this cool little chart down here would be in color, but there are words to tell you what colors these things should be, and if you want to color them yourself, go ahead. Here we go. We have more than this in the lab, but the 6 most common, at least in my experience, the 6 most common pH indicators are methyl orange, methyl red, bromethymol blue, litmus, phenolphthalein, and a thing called indigo carmine. Now, methyl orange, I have some of these here. I can show them to you. Methyl orange is this guy right here. Methyl orange. Methyl orange in the bottle is orange. On its own, it's orange. When you add methyl orange to a solution that is acidic, it turns red. That's why it says red over here. When the pH, so if we look here, neutral has a pH of 7. I want you to add the numbers up top here. So 7, and then moving left, it will go 6, 5, 4, 3, 2, 1, 0. And on the right-hand side from 7, I want you to go 8, 9, 10, 11, 12, 13, 14. Methyl orange, if the pH is 3 or lower, methyl orange will be red. If the pH is about 4.5 or higher, it'll be yellow. What do you think you're going to get if the pH is between 3 and 4.5? Where are my artists? What happens? What do you get when you mix red and yellow? It's not brown. Red and yellow make? Red and yellow make?
Orange.
Orange, thank you. Orange. So when you add methyl orange to something, it will change color based on the pH. pH is less than 3, it'll be red. pH greater than 4.5, it'll be yellow. Between 3 and 4.5, the pH will be in orange. Methyl red is similar, but the change happens at a different spot. Methyl red turns red as you go down from 5. It's about 4 3/4. It turns yellow at 6 or higher, and again, between about 4 3/4 and 6, in between there, you're orange. Bromethymol blue is a little different. Bromethymol blue, guys, stop talking, please. So close to being done. Not like emotionally, but like the notes. Bromethymol blue turns yellow if the pH is lower than 6. It turns blue at a pH greater than about 7.5, which means what color is it in the in-between? It's green. Yellow and blue do not make brown, they make green. Litmus. Litmus is a nice one to use as well. It doesn't tell you, well, litmus will go red in an acid, it'll go blue in a base, and it's a hard line between those two. But litmus, I've got some litmus here. Litmus doesn't come as plain old litmus. Litmus comes as either red paper or blue paper. So the way you use litmus paper is you say, okay, if I take red litmus and I put it in something and it stays red, that doesn't tell you anything. Because anything here will be red. From 7 all the way down to 0, it's going to stay red. But if you take blue litmus paper and blue litmus paper turns red, now you know, by using both of these, you know you have something acidic. Likewise, if you take blue litmus paper and put it in something, it stays blue. It could be neutral, or it could be basic. If you take red as well and put it in there, and the red turns blue, you know you have, using the two together, you know you have something that's basic. But if you take red and put it in and it stays red, and blue and it stays blue, then you know the pH is neutral. It's 7. It's right in the middle. Red will stay red at 7. Blue will stay blue at 7. On the other side, both will change the appropriate color. Okay, so that's litmus.
There's something like pH.
Which one, sorry?
Pregnancy test?
No, it's a hormone test. It's not a P. To my knowledge, no. It's looking for something else in your urine. I mean, I've got pretty good knowledge of pregnancy tests. My wife has used them a number of times, at least twice, because I have at least 2 children. At least twice, I have in my life have been forced to use a pregnancy test. Well, not me, but been present when my wife used them. I wanted to know if she was pregnant. I was there. Phenolphthalein. Phenolphthalein is one that you will play with as well. It is colorless until the pH hits about 8.25. No, colorless is colorless.
Like nothing. Look into the like translucent.
Like you can ooh, this one's starting to crystallize going now. Yeah, like no color. Clear.
So translucent, like the window.
Clear, like the glass. Clear, no color. And it turns pink, like this pink, a very vibrant pink in a basic solution. Indigo carmine is blue down here. You can't see it. It's hard to read, but it's blue until the pH hits like 11.5. And then it starts to turn green, and it's yellow only at the most basic of solutions. It's green in between here. So if you use indigo carmine and the thing turns yellow, you need to be very careful with what you have, because that's a very, very basic solution. Don't get it on your clothes or your hands. Then there's a cheater one. Since in the recent years, there is a Cheaty indicator. I want you to break it off like this. Every single pH value gets a little line down here. And the Cheaty indicator is what's called universal indicator. And the reason it's Cheaty, it's because using it feels like you're cheating. Every single pH value gets its own color. There is zero thought you have to put into this. Every one of these bands is you take the strip. I'm not letting you use it because, again, it's cheating. I'm going to make you do more work with the other stuff. It's a strip of paper. Guys, put your phones away. You put the paper in whatever you have, and there's like at least 14 colors. There might even be in-between shades to give you like half pH values. And then you just take the little carton and you twist the carton until your strip lines up with the color you have, and it tells you exactly what the pH is. It's the development of universal indicator took all the fun out of playing with these guys. But those are pH indicators. You guys are going to do a lab for me tomorrow, letting you play with a couple of these different ones. You're going to use methyl orange, bromethymol blue, litmus, and phenolphthalein. That guy, that guy, that guy, and that guy, to test a bunch of different solutions and to determine whether they're acidic or basic. And that's it. That's all we're talking about today. In addition to the 2 pages that I start already, I'm going to give you 2 more. What I want you to do for the rest of class is these sets of questions. Take a look at this page here. In addition to what I assigned previously, I want you to flip 1 more, and I want you to do this page as well. Do not do the page entitled Acids versus Bases. Just go up to the bottom of what's labeled page 85 there. So I think there's 4 pages I want you to take a look at. Use the time that you've got left. There's about 10 minutes left in the block. You can reasonably get most of this stuff done. And then tomorrow we're going to take a look at 2 lab activities that I want you to do as well. If you have nowhere to go, okay, grade 10s, if you have nowhere to go tomorrow during tutorial, I would encourage you to come here, because there's a bunch of stuff, like there's 2 lab activities I want you to get done before spring break, and you'll have time to work on any of these questions. My D block will probably be sticking around. Your C block, you guys are welcome to come here. 60 students all working on science is kind of a science teacher's dream, so feel free to come here for a tutorial tomorrow if you've got nowhere else that you have to be. You've got your task. On your mark, it's set, giver.